Hi everyone, I'm going to show you how to do a neutralization slash titration type of problem because that's the next section that we are on here in our acids-base unit. So I'm going to do 4 separate problems for you. Please follow along because these are the ones that you are going to be doing on your Schoology assignment and going forward. So neutralization is where you take an acid and a base and you mix them together and you get water and then you get an ionic compound. So basically you are doing a double replacement reaction with an acid and a base. So when you come across a neutralization, or a titration is another word for it, the very first thing that you want to do is write the balanced equation. So in this particular problem, what is the molarity of a solution of HCl? So here's my acid. If 20 milliliters of this solution requires 17.56 milliliters of 0.1258 molar NaOH. So those are my 2 reactants. So the first thing I want to do is write that balanced equation. So HCl plus NaOH. I'm going to do a double replacement, and this is going to make water and NaCl. Now I want to check to make sure that this is balanced. 1 plus 2 hydrogens, a chlorine, a sodium, an oxygen, and an oxygen. So yes, this is balanced. The next step you want to do is you want to look to see what they give you. So I have 20 milliliters of HCl, and it is looking for the molarity of HCl. It gives me 17.56 milliliters, and it gives me the molarity of NaOH. So if I have milliliters and molarity, I can find moles of NaOH. So that's exactly what I'm going to do here. So I'm going to turn the paper a little bit so I can write. So if you remember, molarity is moles over liters. So I'm going to find the moles of NaOH that I have from the milliliters and the molarity. So I have 0.1258 molar equals X. That's the moles of NaOH. Over my liters. So 17.56 milliliters is actually 0.01756 liters. So to solve for moles, I'm basically going to do a cross multiply. So then my moles NaOH is going to be 0.1258 times 0.01756. So I get 0.002209. So that's moles of NaOH. Since I'm trying to find the molarity of HCl, what I'm going to do now is I'm going to use the balanced equation to calculate the moles of HCl. And I can do that using the mole ratio from the balanced equation. So 0.002209 moles of NaOH. Do a short stoichiometry step here, so mole ratio. So from the balanced equation, there's 1 mole of NaOH. And I'm going to moles of HCl, so this is 1 mole of HCl. Is it always going to be this nice where it's 1 to 1? Of course not. So that's why it's crucial that you have a balanced equation. So I'm going to end up with the same amount of moles of HCl. Now I can solve for molarity because molarity is moles over liters, and they give me the milliliters of HCl. So I can do 0.002209 moles over the liters, 0.02000, and that's going to get me the molarity of HCl, which is 0.1105. And that would be my final answer. So if it's asking for molarity, first you find the moles of the one that they give you, your volume and your molarity, and then you use the balanced equation to do a mole ratio to solve for moles of the other, and then you take the moles, divide by the liters that they give you. I'm going to do another problem just like that. This time they're asking you for the molarity of H2SO4, and you have NaOH. So again, the very first step, write your balanced equation. So H2SO4 plus NaOH produces, do a double replacement reaction, you get Na2SO4 plus H2O. So to balance, two sodiums. So 2 H's here. I have 2 plus 2 for a total of 4 H's. So I need a 2 in front of H2O. When you are doing these equations, you are generally always going to have to balance the water on the product side and then one of the reactants on the reactant side. So I'm going to do the exact same thing I did in problem number 1. So I have the volume and the molarity of NaOH. So I'm going to solve for moles of NaOH. So I have 0.5609 equals X moles NaOH over the liters, 0.01393. So this is going to get me 0.007813 moles of NaOH. Now I'm going to convert moles of NaOH to moles of H2SO4. And again, this is where the balance equation comes in handy. So 0.007813 moles of NaOH. So from the balanced equation, there are 2 moles of NaOH. And there's 1 mole of H2SO4. So 0.007813 divided by 2. So I'm going to get 0.003907 moles of H2SO4. So now I can take that moles and put it over the liters of H2SO4 to get the molarity. So 0.003907. This is moles of H2SO4 over the liters, which is 0.02500. And you will get 0.1563, and that's the molarity of the H2SO4. Now the next 2 problems here are asking you to find the volume, so it's a very similar process throughout until you get to the final step. So again, the first thing you're going to do is you are going to do your balanced equation. I have KOH, I have H3PO4. So H3PO4 plus KOH is going to get me K3PO4 plus H2O. So 3 Ks, I need 3 KOHs, and I need 3 waters. Okay, so I have 25 milliliters of 0.115 molar of phosphoric. This is H3PO4, phosphoric acid. So I'm going to find the moles of H3PO4. So I'm doing exactly what I did in the previous problem. .115 times 0.025 gets you 0.002875. So that is moles of H3PO4. Okay, so do your mole ratio using your balanced equation. So 0.002875 moles of H3PO4. Trying to get moles of KOH. So 1 mole of H3PO4 goes on the bottom. And I have 3 moles of KOH. So 0.002875 times 3, that gets you 0.008625, and that is moles of KOH. So if I wanted to find molarity, now I would divide by the liters, but I'm trying to find the volume, which is liters. They give me the molarity, so in order to solve for liters, I'm going to do moles divided by molarity. So moles divided by molarity gets you liters. So the molarity is 0.2. So 0.008625 divided by 0.2 gets you 0.00431. I probably shouldn't have rounded the 3 sig figs here because of 0.115. I'm sorry about that. This is 0.0431 liters. If they wanted it in milliliters, just multiply by 1,000. And you would get 43.1 milliliters. Same thing for the last problem here. So I have H2SO4 with NaOH. So I'm going to write my balanced equation, which is the same balanced equation from my second problem I did, to NaOH, which gets me Na2SO4 plus 2 waters. It wants you to calculate the volume of NaOH, so I'm going to find moles of H2SO4 because they give me milliliters and molarity. So 0.6053 equals X moles of H2SO4 over 0.02660 liters. So that gets you 0.01610 moles of H2SO4. So now I'm going to convert to moles of NaOH. So 0.01610 moles of H2SO4. Trying to go to moles of NaOH. So 1 H2SO4 in the question, or in the equation rather. 2 moles of NaOH on the top. So multiply 0.0610 times 2. You get 0.03220, so that's moles of NaOH. Again, liters is moles over molarity. So you're going to do 0.03220 moles over the molarity, which is the 0.25. And you will get your answer of 0.129 liters. If you want milliliters, multiply by 1,000 and you'll get 129. So that is how you do neutralization problems. Hopefully this helps you guys. If you need help, please send me a message on Schoology. Thanks.